X is going to represent the daily high temperature in La Crosse in degrees Fahrenheit throughout the month of June, and all the temperatures have been routed to the nearest 10. So we have options of 60, 70, 80, 90, and 100, and we're given their probabilities in our table. If you wanted to convert from Fahrenheit to Celsius, you would use the equation 5/9 of the quantity X minus 32. What we want is the expected value of the daily high temperature in June in Celsius. We'll start by finding the expected value in terms of Fahrenheit, and we can do that by going directly through our table and using our formula for the mean, or expected value, that says you sum up x's times their probabilities throughout the whole table. So we'll get 60 times 0.05 plus 70 times 0.25 plus 80 times 0.45 plus 90 times 0.2 plus 100 times 0.05. And what this will give us is 79.5. This is the expected temperature in degrees Fahrenheit. We want to convert to Celsius, and so we can see that we have a function that we can write as a linear function. If you take 5/9 of x minus 32 and you distribute the 5/9 through, you'll get 5/9 x minus 160 over 9. We want this to be in the form of c plus d times x to represent it as a linear function of x. And this is true if we let c be the constant of negative 160 over 9 and let d be 5 out of 9. So if you want the mean of c plus dx, which would be our temperature in terms of Celsius, we have a rule that says you take c plus d times the mean of just the x's. So if we plug in all of what we have, c is negative 160 divided by 9 plus d of 5/9 times our mean that we found of 79.5. And this gives us a temperature of 26.389, and this would be in degrees Celsius.